Welcome, I'm Felipe Espinosa, professor in the Engineering School Electronics Department at University of Alcalá, Spain, and the topic of this lecture is an introduction to sensing as part of mechatronic system. This MOOC has been supported by the Erasmus Plus project Graceful Equalizing of Mechatronic Students, abbreviated GEMS. The schedule of this lecture includes the following sections. We will present the objectives. After that, we will introduce the main basic concepts about sensing as well as sensor classification with some examples. Next section will deal with the main functional components of a sensor module and with their most well-known applications: variables monitoring and measuring signal for automatic control. Finally, we will review the main conclusions and list the reviewed bibliographic references. The MOOC is focused on the following aspects. Firstly, understanding the role of sensors to perceive the environment. Secondly, knowing the common functional parts and applications of sensor modules. And thirdly, describing the main sensors included in the GEMS project prototype. However, we will not focus on physical or chemical nature of sensors, nor aspects related to fabrication process of sensing elements. Let's first take a look at basic concept of sensors. We will pay attention to the relevance of senses in human beings: taste, smell, vision, hearing, and touch. Do you remember the blind man's bluff game? It is a clear example of the key role of the senses to perceive and interact with the environment, that means with the world. There is no doubt that senses are vital for human perception, cognition, and behavior. Now, we will try to explain why mechatronic engineering takes as reference living beings' behavior. It is well known that measurement of internal variables is necessary to self-regulate and maintain stability of vital human processes, such as balancing of temperature, calcium, blood pressure, and sugar, etc. In the same way, sensors involved in biology processes are commonly analyzed and imitated by robotics and mechatronic engineering. Following with basic concepts, a sensor can be defined as a device that helps to detect any change in physical quantity. After observing the change, a sensor processes the detected signal and presents the results. A sensor should be sensitive to the main property it is measuring, but insensitive to other properties like noise in the same context. Moreover, a sensor should not influence on the property it is measuring. There are different criteria to classify the sensors. Basically, we select the following. Sensors can be proprioceptive or stereoceptive. Proprioceptive is a sensor that measures variables internal to the system. For example, the engineering temperature sensor in a vehicle. Stereoceptive is a sensor that measures variables external to the system. For example, the ultrasonic sensor for parking assistance in a vehicle. On the other hand, can be active or passive. We talk about active sensors when it emits energy and measures its response. For example, a vehicle radar, LiDAR, or sonar to detect obstacles along the trajectory. However, if the natural phenomenon is detected without any energy emission, we say that the sensor is passive. For example, the on-off seat belt detector in a vehicle. Finally, we can classify sensors between analog and digital. An analog sensor produces continuous time and continuous level signals. For example, the analog tachometer in some cars, but a digital sensor produces discrete time and discrete level signals. For example, the numerical speedometer in some cars. In robotic and mechatronic context, sensors are the key devices to perceive and interact with the environment in a natural and intuitive way. The figure shows different sensorial tasks implemented in a humanoid. Some of them emulate the human senses: vision, sound, touch, taste, and smell. Others allow through the robot wireless communication, speech capability, positioning, pressure detection, etc. There is a huge amount of sensor devices and modules available for mechatronic designers. The figure shows examples of commercial sensors. Some of them present single format, such as a phototransistor, LDR, and flex sensor, marked in red in the slide, but others are included in an electronic board, such as the ultrasonic, color, or vibration sensor, marked in green in the slide. Also, the GENS prototype sensors play an important role. The Rubik car has been specifically designed to highlight the relevance of sensing in a mechatronics system. This electronic board implements a microphone device as sound sensor and an ultrasonic car as distance sensor. Besides, the Diamond car, focused on control tasks, requires sensors to carry out its functionality. This is the case of the current and the motor axle speed sensors, based in Hall effect, or the thermistor used for temperature measurement. The physical appearance and commercial references of all of them can be seen at the right side of the table. Going on the lecture schedule, we will tackle with the components of an electronic sensor module and the main applications. A sensor module includes two main functional blocks: signal acquisition and signal processing, both linked by an analog to digital converter, named as ADC. The figure shows the components of each block, allowing the sensed information to be presented and analyzed. Once the physical variables generates a physical stimulus, it is changed into electrical signal by the sensor transducer. Then, the raw analog electrical signal is conditioned to enhance its quality and accuracy. The signal conditioning mainly covers tasks as filtering noise and amplification, but others can be necessary, such as linearization, multiplexing, etc. The resulting analog signal is digitalized by the ADC. This way, the signal can be properly processed by the specific software application into a digital device such as a microcontroller. After that, the signal is ready to be monitored by the final user. At the top right side, we can see an example of how the voice of a speaker is captured. The small electronic board includes a microphone as transducer and the rest of the signal acquisition subsystem. At the bottom right side, we can see an example of electronic board where the previous one can be inserted. Then, the analog signal is converted, processed by a microcontroller, and monitored on a display. The general applications of sensor modules are monitoring, information, and automatic control. Firstly, we take a look to monitoring variables for the user. The figure shows an example of personal wearable sensor device. It offers variables of interest for runners. instantaneous and average speed, error rate, track trajectory, etc. The right figure shows how an infrared detector is used in maintenance tasks such as detecting possible faults in an electrical installation. In feedback control system, the measured signals by sensors are compared with different references to obtain the signal errors that will be compensated through a controller. This way, sensors play an important role in automatic control system. This is the case of many sensors implemented in a vehicle: radar, infrared, camera, inertial, GPS, pressure, etc. We are arriving to the last part of the lecture. Time for conclusions and references. Summing up the session, we review the main ideas about sensing. Sensors are to mechatronic as senses are to human body. They are the interface that allows to perceive and interact with the environment. A sensor module integrates several electronic devices grouped into two main blocks: signal acquisition and signal processing. Transducer and digital processor are the most representative ones of each block. We can distinguish two types of sensor applications: information monitoring and signal feedback for automatic control. And finally, the Mechatronic GEMS demonstrator includes a specific electronic board focused on sensing sound and distance, but other GEMS cards are also require sensors devices. Last slide includes the recommended references. They have been used to prepare this lecture. References from 1 to 3 are related to sensing concepts of theoretical aspects. References 4 and 5 are centered in commercial electronic sensorial modules and applications. Thank you for your attention.